Welcome to cyfs Decentralized Message Board tutorial. We chose Decentralized Message Board as the teaching demo because many people started learning dynamic web development from the message board. We will develop 3 key features for our decentralized message board. First, visit people's message boards. You can visit your own or a friend's message board through cyfs:// his path / messageboard / index.html. If there is no people ID parameter, it means to visit your own message board. All messages will be listed on the message board in chronological order. Every message includes the author, the time, and the content. Second, create a message. There will be an entry to create a message on the message board, and you can post a message to the current message board. Third, modify and delete message. The author of the message can modify and delete his posted message. Now let's create the project. First, make sure you have exported your identity to your computer through CyberChat. Let's verify. If you can see 2 people files under the .cyfs profile file, it means that your identity has been successfully imported to your computer. Next, make sure you have installed Node.js latest stable version in your system. Then, install cyfs-tools and cyfs-tsk-sdk client globally. Finally, create a project with the scaffolding under the folder you want. We enter the tutorial folder. Use scaffolding commands. The project name is Message Board. The template is Message Board Demo. Now we can see that the project has been created successfully. Open the project folder with VS Code. Now, let's install the dependencies. Project dependencies are installed. Let's take a look at the structure of the entire project. There are 4 folders and 11 files in the root directory. Let's explain what they do in order. The .cyfs folder stores the meta information of DEC app. The DOC folder holds project-related documents. SRC is the main folder of the project. The Tools folder stores the tool programs related to the project. The /ignore file. This is the /config file. This is the gitignore file. cyfs.config.json is the configuration file for publishing this app to OOD. Move-deploy.js is the necessary file to transfer script before publishing this app to OOD. Package.json is the project configuration file. This is the prettier config file. Here's the README file. Service pack is the server-side packaging configuration file for publishing this app to OOD. This is the TypeScript config file. This is the global declaration file. Note that The app ID property in cyfs config.json is calculated by owner ID and app name. It cannot be modified by oneself. There are some places in the code that must use DEC app ID, then use this ID. There are 3 subfolders under the src directory. Common is the code that can be reused by the front end and the service end. Service is the server-side code. 3W is the front-end code. Under the src common cyfs helper folder, there are several files. These are encapsulations of meta-client stack and some common complex operations to make them easy to use. Now let's modify the DEC app-related identification parameters. Open src common constant.ts file. Modify the DEC ID base 58 constant value in the source code to your own DEC app ID. Change the app name constant value to your own DEC app name. Now let's learn about object modeling. In the cyfs network, all custom objects must inherit the cyfs base object, named object. This named object will provide some common properties. Every object will have these properties. Named objects are meaningful, immutable object data that have determined owners. If you want to know about a named object, please read the tutorial documentation corresponding to this. In order to achieve stable encoding DEC object, we use the protobuf tool. Protobuf is a widely used protocol for serializing structured data. Its stable coding characteristics are exactly what we need. Use the proto description file to define the structure of the data. Then, use the proto-C compiler to generate the source code. It can write and read structured data in various languages, in various data streams. Even can it update data structures without breaking deployed programs compiled from old data structures. Now we use protobuf to write the description file of the message object. Open src common obj.js object proto.proto in our message board. Each message is a named object. We call this named object representing the message object. Message object contains 2 properties: key and content. Key is the unique identifier of the message object. Content is the text content of the message object. Now use protobuf to generate static stub code. First, open the package.json file. We see these 2 commands. The first command is the install ts proto-c generate globally. This can generate the corresponding declaration file for us. Then, modify the executable permission of the proto-c program in the tools directory. Second command is to use proto-c to generate static stub code. Now we open the terminal in the root directory. Execute these 2 commands separately. After execution, we can see object proto.pb.d.ts and object proto.pb.js file. In the src common obj.js folder, open this declaration file. We can see the stub code for the message object. we explain the four most important contents. First, we can see to read and set the key value, use getKey and setKey respectively. Use getContent and setContent respectively. Use serialized binary method to encode the message object as a uint 8 array format. Use deserialized binary to decode a uint 8 array format message object to a message object. Now let's complete the object definition of message object. Open SSC common obj.js message object.ts. This file is the complete object definition file of message object. It is to be noted here that in the future, with the help of tools, developers only need to write .proto files to generate all the code. But at this moment, we have not finished this tool. Also, we should support manual extension of DEC object, so it's no harm to know the underlying code. The process is relatively mechanical and cumbersome. Basically, just fill in the template after having the proto file. Here we give a simple explanation. The first is to define the immutable part DEC. This is to define DEC type info of the object. There are two methods. Object type is the type of the application object. Sub-DEC type is the existence form of the DEC system field. Disable means none. Option means optional. This is to define DEC content of the object. It inherits cyfs-tsk-sdk DEC content. Here are some properties and methods of DEC content, corresponding to the key and content in the proto description file respectively. This is type info. This is try to proto. Next, define DEC content decoder of the object. It is inherited from cyfs-tsk-sdk DEC content decoder. Type info and try from protocol are required here. Here defines DEC of the object. It is inherited from cyfs.namedObject DEC. Keep the default implementation here. The same is true for the DEC decoder of the object. It is inherited from cyfs.namedObject DEC decoder. Also keep the default implementation. Now define the variable part body. First, define the body content of the object. It is inherited from cyfs.protobuf body content. Try to proto requires us to implement set an empty object. This is the body content decoder of the object. It is inherited from cyfs.protobuf body content decoder. Super is needed to be implemented. Try from proto is also needed to be implemented. This is the helper class to define ID. You need to pass these two parameters in super. This is the object's ID decoder. Pass this parameter in super. This is the object's builder, inheriting cyfs.nameObject builder. keep the default implementation. At last, we integrate immutable DEC and mutable body. This is the builder of the object. It is inherited from cyfs named object builder. Keep the default implementation. This is the object we are actually going to use. It is inherited from cyfs.named object. The create method must be implemented here. This integrates the body content and the builder of the previous DEC content. Eventually generates the object we want. Here are the two methods to get object properties. Finally, the decoder of the object. It is inherited from cyfs.named object decoder. Just pass in these three parameters in super. At this point, our message object definition file is all complete. Did you find that you have to define as many as 12 classes to define one object? It is too difficult, but it is not that complicated. The entire object definition file is actually a fill-in-the-blank question. If you want to define more custom objects, then just refer to this file to do fill-in-the-blank questions. Now, we design the storage path of the message object on root state. Open the src-duc object model.md file. Based on the previous introduction to object map-based root state section, we know in cyfs we have standard named container objects like object map, object set, etc. These standard named container objects are used to store named objects. Each named object is represented by a key1, key2, key3 path. A message object is also an instance of a named object. These objects should be stored in a named container object, representing the list of message objects. This named container object also has its own path. We call it messages list. That is to say, only message objects stored in a specific object map message object are the messages to be displayed in the message object list. This is the storage structure on root state. Key is the key value of the message object. Value is the message object itself. Now, let's use the root state API to implement CRUD operations of messages. Now, you have already understood the basic of root state, finished modeling the message object, and designed the storage path of the message object on root state. However, you may ask, how to do CRUD operations to objects on root state? The answer is to use path-op-env, the short for root path operation env. In cyfs, every root state, for example, A, B, C, except for leaf nodes, every level is an object map. Leaf nodes can be any object ID or object map, object set format containers, etc. In order to solve the data constancy problem, path-op-env uses the transaction mechanism based on path log to realize the operation of the object data on the root state. A transaction is a series of operations to do a single logical unit of work, either fully do or not do at all. A logic unit of work has to meet ACID requirements to be a transaction: atomicity, consistency, isolation, and durability. If you want to do CRUD operations on objects on root state, A complete path of ENV transaction consists of 3 steps. Step 1. Lock the path. Step 2. Do transaction operations. Step 3. Transaction commit. After knowing this, we use root state to implement functions to do CRUD operations to messages. Let's first implement the add-message function. Open the src service routers publish messages.ts file. To add a message, we need 4 steps. Step 1. Receive a new message object. Decode with message decoder. After decoding, get the message object. Step 2. Use path of env to lock the new path according to the key of the message object. We base on the key value of the message object to get the corresponding path and lock the path. Step 3. Save the message object to NON using NON object info objects. Then, use the put object method on NON service to save it in NON. Step 4. Use path of env to perform the insert with path operation to add a new message object to message list. Here we use insert with path for transaction operation. Through this operation, the new message object is added to the message list. Finally, commit this transaction. This is our add message function. Now, let's implement the modify message function. Open the src service routers update messages.ts file. To modify a message, we need 5 steps. Step 1. Also receive a new message object. This message object sets the key value to be modified. Use message decoder to decode the message object. Step 2. Use path of env to lock the object path according to the key of the message object. Step 3. Save the new message object to NON by using the property value of the message object. We get the NON object info of the object. Save to NON through put object in NON service. Step 4. Use path of env to execute set with path to perform the update operation. Finally, commit this transaction. In this way, we have realized the function of modifying the message. Now let's implement the delete message function. Open the src service routers delete messages.ts file. To delete the message, we need 4 steps. Step 1. Receive the message object to be deleted and specify the key value of the object to be deleted. Use message decoder to decode the message object. Step 2. Use path of env to lock the object path according to the key of the message object. Use the key value of the message object to determine the path it points to. Use lock to lock this path. Step 3. Use path of env to perform remove with path operation. Use remove with path to perform delete transaction. Finally, commit this transaction. In this way, we have completed the function of deleting the message. Finally, let's implement the query message function. Open src service routers retrieve message.ts file. To query a message, we need 3 steps. Step 1. Also receive the message object to be queried. Specify the key value to query. Use message decoder to decode the message object. Step 2. Use pass-op-env to read the message object ID to be queried. Use getByPass to get the message object ID according to key value. Finally, get the message object on NON. Use the getObject method on NON service to get the message object. In this way, we have realized the function of querying message. Now let's run and debug our own message service. First, let's take a look at how DEC service works end-to-end. The cyfs protocol is an overall upgrade to the HTTP protocol, so we will try to keep approximate semantics as HTTP. The core process is cyfs-tsk app uses cyfs add HTTP protocol to send requests to cyfs runtime. cyfs runtime sends to gateway using cyfs add BTT protocol. Gateway sends to cyfs DEC service using cyfs add HTTP protocol. cyfs DEC service sends response content to gateway using cyfs add HTTP after handling the request. Gateway sends to cyfs runtime using cyfs add BTT protocol. Last, cyfs runtime sends to cyfs DEC app using cyfs add HTTP. This is the complete end-to-end workflow of DEC service. Since the cyfs add HTTP protocol will be used directly by DEC app developers, its design is concise, easy to understand, and relatively stable. Please check the documentation for this tutorial to learn more about how DEC service works end-to-end. Now, let's dive into the DEC service launching program. First, let's take a look at App Manager. App Manager is one of the basic services in the cyfs protocol, mainly used to install and run DEC app. App Manager uses a Docker container to run DEC apps process in order to run DEC app more securely, enabling the stack to authenticate DEC app requests and checking whether the DEC ID it carries is forged. Now, let's take a close look at the service launching program. The complete code of the service launching program is in the src service entry appstartup.ts file. The entry of the service launching program is the main function. It mainly has 3 steps. Step 1. Open the service log. Step 2. Open and wait for stack to go online. Step 3. Register the router module on stack. Let's first take a look at opening the service log. Logs allow us to quickly find and locate problems, which is very helpful in solving online problems. The storage paths of application logs are slightly different under different operation systems. Under the Linux system, it is stored in the cyfs log app DEC ID path. We use the enable file log method to enable service logging. Next, launching and wait for the stack to go online. We can easily open and wait for stack to go online by importing the waitStackOD method in cyfs helper. Finally, register the router on the stack. We use addRouters method to register routers in batches. To improve development efficiency, the addRouters method realizes this function by traversing routers objects that encapsulates all router modules. It completes two main missions in each round. The first is to dynamically set access permissions for the request path. Here we only open all permissions to owner DEC for each request path. All refers to read, write, and call. Next, use the add-post-object-handler method to mount the router module to the specified request path on the stack. The above is the launching program of the service. Now let's learn to run and test the DEC service. We recommend developing DEC app by separating the front and the back end. So far, the DEC service of the message board has been developed. Next, we publish DEC service to OOD and debug each function of DEC service independently. First, compile and package the project. In the project root directory, open a terminal and run the following command. You can see a new deploy folder in the project root directory after the command is executed. Deploy is the folder to publish to OOD, which contains all TS files in the project, compiled by JS files. Next, copy the src common obj.js object-proto-pb.js file to deploy src common obj.js object-proto-pb.js. Now, we publish the DEC service to OOD. This process involves how DEC apps package and publish. Please check the documents for this tutorial. Now, let's publish this service. First, we open the cyfs browser. Then, in the project root directory, open a terminal. Run the following command. You need to be patient here. When the terminal appears, upload DEC app finished and it shows the installation link. Congratulations! It means that our DEC service has been successfully published to OOD. Now we copy the link corresponding to cyfs app install link. Next, we will use this link to install DEC service. DEC service has been published on OOD. Now, let's install DEC service. Before installing the DEC service, it is necessary for us to understand how App Manager installing DEC app works. When the user installs the specified version of the DEC app on the OOD, OOD will do the following 4 things. First, according to the target of OOD, find out whether there is a service target.zip file in the corresponding directory. Zip is used to reduce publishing and downloading size. If there is this file, just unzip this file to the cyfs root app ID folder. Second, find out if there is a web folder in the corresponding directory. If there is, download the web folder to the cyfs root web app ID folder. Then add the folder to the cyfs stack and get a new web directory ID. Third, if the DEC app has service, It will execute the service install script corresponding to the install configuration in the service package.cfg file in the project root directory. If the DEC app has service, it will execute the service start script corresponding to the start configuration in the service package.cfg file in the project root directory. Now, let's install DEC service using cyfs browser. First, copy the cyfs link after a cyfs app install link. Go to the cyfs browser and open the DEC app store page. Click the Install via URL button. Paste the installation link. Click the Get App Info green button. Next, you can see the historical version of DEC app in the version list area of the page. We choose the latest version. Click Install. At last, we return to the DEC App Store page. Click the Installed green button at the top of the page. You can see the installed DEC service. If it says installing, please be patient. Our DEC service is already running on OOD. Now, let's debug the function of CRUD operations to messages. Let's first understand how to write a test program. The main function of the test program is to start a client to interact with the service in order to test the function of each interface. In principle, it is to start a runtime stack, open and launch runtime stack. Use runtime stack to initiate a request to DEC service. Let's compile the debug file first. In the project root directory, open a terminal. Execute the following commands. After execution, all test script files are in deploy src service test folder. Now, let's debug the publishing message feature. The corresponding source code is in the src service test publish message test.ts file. The main entry is the main function. It needs to complete the following 3 steps. First, initialize the runtime stack. Then, set the new message key and content. Last, make the request. Alright, let's test it. In the project root directory, open the terminal and execute the following command. We can see that the client terminal prints out the key of the new message object. The result is OK. It means that our interface function works fine. We have successfully conducted joint debugging publishing message function with the service on OOD. If there is an error inside the service on the OOD, how should we locate the problem? Actually, on OOD, we can easily view the logs on the server side. The storage paths of the service logs in different operating system environments will be different. In Linux, it is under the path cyfs log app DEC ID. Next, we debug the query message function. The complete source code is in the src service test retrieve message test.ts file. The main entry is also the main function. It needs to complete the following three steps. First, initialize the runtime stack. Then, set the key of the message object to be queried. Last, make the request. Let's try. Open deploy src service test retrieve message test.js file. Set the message key constant in the main function to the message key string printed in the client console in the previous step. Remember to save the changes. In the project root directory, open a terminal. Execute the following command. Now we can see the client console prints the key and the content. It means that our interface works fine. The next step is to debug the update message function. The complete code is in src service test update message test.ts. The main entry is also the main function. It needs to complete the following three steps. First, initialize the runtime stack. Then, set the key of the message object to be modified and the new content value. Finally, make the request. Let's try. Open deploy src service test update message test.js file. Set the message key constant in the main function to the message key string printed in the client console in the previous step. After modification, in the project root directory, open the terminal and execute the following command. It means that our interface works fine. Finally, let's debug the delete message function. The complete source code is in the src service test delete message test.ts file. The main entry is also the main function. First, also initialize the runtime stack. Then set the key of the message object to be deleted. Finally, make the request. Let's try. Open deploy src service test delete message test.js. Set the message key constant in the main function to the message key string printed in the client console during the debug publish message function part. After modification, in the project root directory, open a terminal. Execute the following command. Our interface returns the expected result. Now let's learn front-end development of DEC app. First, let's take a look at the front-end structure of the cyfs DEC app. The front-end code will be completely saved on OOD when it is installed, and must match the corresponding backend. cyfs-tsk fully supports TypeScript. It provides the same development experience of both service and client for web developers. We can only use TypeScript to basically complete the development of DEC app. The front-end page of the DEC app is accessed through a link. A link is the link used to handle the link of in-app pages in DEC app. The front-end page is the main form of the application page. If you want to learn more about a link, Please check the documentation for this tutorial. Now, let's learn about cyfs front-end initialization. We open src3w-initialize.ts file. This file contains the code related to front-end initialization. Front-end initialization is mainly about 3 steps. Step 1. Select the OD environment or a specific zone in the emulator environment. Step 2. Meta client initialization. Select beta. Finally, open and wait for the runtime stack to go online. Now, we start to learn the development of front-end pages. The front-end pages is at src3w pages message board. The front-end page is the most direct interactive terminal for users in DEC app. To make front-end interaction as simple as possible, our message board system has only one front-end page. This page contains an input area to post messages and a display area to show message list. Now, let's implement the function of querying the message list. When implementing the function of querying the message list, we will use list method on cyfs.globalStateAccessStub instance to paginate the message list. We need to understand how it works. When we need to query a list of objects under a certain path, you can use the list method on the cyfs.globalStateAccessStub instance for pagination. This list paging query method is implemented by enumerating the sub-objects of an object map. The range of the queried object list is from size multiplied by index to size multiplied by index plus 1. Now let's learn the specific implementation of query message. There is a function to initiate a query message request in src3w apis message.ts file. We mainly call the query message list method list messages by page to query the message list. After getting the data, display the message list. Querying the message list needs to complete the following 3 steps. Step 1. Use the root state access stub method on the stack to get instance of global state access stub. Step 2. Call the list method on the global state access stub instance to get the paged key value list of messages list. Step 3. Traverse the key value list. Call the retrieve message method to do a query message request. After decoding, get the final message object. After getting the properties of the message object, construct a message item object and return. Now let's learn to publish a message. The function to publish a message is also in src www.apis-message.ts file. It contains a text input box and a leave a message button, page elements for posting a message. The front-end interaction process is that after inputting the text content of the message in the input box, click the Leave a Message button. You can publish a new message and refresh the message list. The following 3 steps need to be completed. Step 1. Create a new message object, message. Step 2. Initiate a publish message request. This is the required path to publish a message. Last, parse the response request. Return a response object. Then pass it. Now let's learn to modify the message. The function that initiates the request is also in the src3w apis message.ts file. The page element to modify a message is contained in a message component. There is a modify button in the bottom right corner of the message. After clicking the button, it will show a text input box and a submit button. The corresponding page elements are in src www components message item file. Here, we need to complete the following 3 steps. Step 1. Create a message object message according to the key field and the new content of the message object to be modified. Step 2. Initiate an update message request. Last, pass the response object. The last one is to delete the message. The function that initiates the request is also in the current message.ts file. The page element to remove message is contained in a message component. There is a delete red button in the lower right corner of the message. It is also in the message item component. This is the delete button. We need to complete the following 3 steps. Step 1. Create a message object message according to the key field of the message object to be deleted. Step 2. Initiate a request to delete the message. Finally, pass the response object. After completing the front-end page development, let's now preview the effect of the front-end page. In the project root directory, open a terminal. Type the following command. We can visit localhost port 8088 in cyfs browser to see the effect of the front page. Here we use Webpack for packaging. Wait a moment. It is good. Open browser. You can see the final front-end effect. Through previous learning, we have implemented a message board front-end display page. Now, let's publish front-end page together with the DEC service to OOD. Before publishing, we need to modify the configuration file. Open cyfs.config.json file in the root directory. We increment the version number by 1. Modify the web configuration. Now let's compile and package the project. The front end is developed using the React framework, packaged with Webpack. Open a terminal in the project root directory. Run the following command. We can see a new disk and deploy folder. This is the front-end packaging product generated by Webpack. Now, we publish DEC app to OOD. Open the cyfs browser first. Then run the following command. is good. When we see upload DEC app finished, it means that our DEC app has been successfully published to OOD. Next, we upgrade the DEC app in the cyfs browser and check. First, open the DEC App Store page in the cyfs browser. Click the installed green button at the top of the page. You will see an extra update small green sign. At the end of the app name, we click on this little green sign to go to the application details page. Then, on the app details page, we click on select update version. You can see the latest version of the current DEC app. Click the install green button. Next, go back to the DEC App Store page. Click the install green button at the top of the page. You can see that DEC service has been installed. If it shows installing, please be patient for a while. After installation, there is a green Enter sign at the top right of the app info bar. That is the entrance of the front-end page. We click the icon. You can see the entry page of the DEC app. So here we have completed all contents of this tutorial. Now our message board DEC app already has a front-end page that looks good and a service that works fine after careful debugging. If you want to know more about DEC app development, please check the documentation for this tutorial. Thank you all.